Hi everyone, welcome back to our channel. This is the third video of database management system series in which we will try to understand normalization. Normalization is a very important topic when you try to understand how a data should be stored into your relational database management system so that in later stage of time you don't get any issues while dealing with your data. But before we start with this topic, let us revise what we already know about database management system. Okay, so in the first two videos, we understood what is the database management system, what was the importance, what are the kind of database management system that exist, what is the difference between NoSQL and SQL database management system. By this time, we also have understanding that in what condition we should opt what kind of database management system. Okay. So let's move forward. Whatever you can see in my screen is the definition of normalization. So normalization is an approach or a way in which you store your data into database management system so that in later stage of time you don't have to deal with mess around your data. Your data is well organized, your data is reliable, your data is very efficient, and you can always use the data that exists into your database. Okay, so now we'll understand why was normalization needed, like what is the use of normalization. So if you don't use normalization in the real world, you'll find these three kind of issues: anomalies, redundancy, and inconsistency. I know these words are really heavy. I'll try to explain what these words mean, okay, in next slides. So anomaly is an unwanted errors in your data. Okay. Generally, we perform three kind of process in our data, right? We'll try to insert your data, we'll try to update data, and we'll try to delete data. Anomaly is an unexpected error that comes while doing any of this process or all these process. Okay, all these three process. So let's suppose you are trying to insert a data into a table which is very important for you, but it is not letting you insert till you insert some unwanted data. That will be defined as insertion anomaly. Updation anomaly is, let's suppose you have multiple uh, occurrence of the same data into your table. Okay, you updated at one place and you forgot to update on the other. That will lead to an update anomaly. And the third is deletion anomaly. Deletion anomaly is a condition where your data is stored just as at a place and you somehow wanted to delete, or you have deleted that particular record. In that condition, you lose the information that you wanted to retain. That is a deletion anomaly. So our normalization is the process of structuring data into such a way that these three anomalies doesn't occur in your table or in your data at any point of time. Okay. The second is redundancy. Redundancy is unnecessary repetition of data. Let's suppose you have a data which is present in multiple tables or in the same table multiple amount of time. In that cases, not only it is taking extra space in your server, also it is leading a path to an error. Let's suppose you have a multiple occurrence of a same data. It has already took three space. Okay, if you have its occurrence at a three places. Along with that, if you try to update a data into one place and you forgot to update at other two places, it will lead to an update anomaly, an update error. Okay. And the third is inconsistency. If you go back to the same example that I was giving right now, inconsistency, as the name indicate, is the condition where you have inconsistent data. Your data is not consistent. Your information is not consistent throughout the tables. Okay. So this can happen when you have update anomaly. Like you tried to update one table, you have updated it successfully. Your same information is there in other tables, but you forgot to update that. In that case, if you try to fetch the table data from the other tables, the same data, you'll see the difference in the records, right? Let's suppose I wanted to update the address of student XYZ. I had that record in student table, I had that record in address table. I updated that in student table, but I forgot to update in address table. Now my student table has address as Delhi, but my address table has address as Bangalore. In that case, when you try to fetch the address of that particular student for sending a letter or something, you'll find an inconsistent data, right? You don't know at what is the correct record. In that case, you'll again see the error, and normalization is there to help fix this kind of issue also. Now I'll try to show you real example of all three anomalies and inconsistency, redundancy into the same table. So this is my student table. Okay. Here you see some of the department is repetitive, right? So this can be termed as redundancy. The second is anomalies. So first, if you try to understand insertion anomaly, let's try to understand this one. Okay. I am trying to insert a new course. Okay. Let's suppose I want to start a course of database management system here. Okay. But this will force you to insert the record of enrollment date and instructor, right? Which is an insertion anomaly. I just have the course in my mind as of now. I don't have instructor name or enrollment date, but it is asking me to insert those records also. So that is an insertion anomaly. The second is deletion anomaly. Let's suppose you deleted the record of organic chemistry over here. You will lose the information on Professor Brown. That is an deletion anomaly. It should not have happened. If you want to delete organic chemistry detail, you could remove organic chemistry detail, but not necessarily you should remove the record of Professor Brown also. And the third is update anomaly. If an instructor changes name, let's suppose Professor Smith changed his name to Professor to assistant professor or to senior professor, whatever it is, it there is some update in Professor Smith's name. You will have to update it at multiple places. That is update anomaly. If you forgot to update at some other place, it will again lead to inconsistency. So this particular table has all kind of issues. Now to deal with all such issues, we have some concepts of normalization. So what are the core concepts of normalization? Normalization has multiple concepts and they are hierarchical in order. It means you should start with the first concept and then only you can achieve the last form of normalization. But in this particular video, we'll try to tackle with first three forms of normalization, which is named as first normal form, second normal form, and third normal form. Okay. So first normal form basically wants to tackle the issue of redundancy. Okay. It ensures that your table has only one data which cannot be further divided. It ensures atomicity. Okay. In simpler terms, it makes sure that your data is as simpler in a particular table as it could be. Let's see the example. This is a student table. Okay. This is non-normalized table. Okay. This is student table which has student ID and subject. So if you see, each student has multiple subjects. Okay. Which is non-atomic. It means there are more than one subjects with one particular student ID. So to make it one normal in first normal form, what we will do is we'll divide this. We'll have multiple rows of the student ID with different subjects. Now this is atomic in nature. It means there are no multiple values present in a particular row. So this is in first normal form. The second normal form is uh, the process of tackling partial dependency. It means it want to ensure that your non-key attribute is fully functionally dependent on your primary key. Now, what is the primary key? What is the functional? What is non-key attribute? I'll try to explain. So, the key that is very important in a table that is not going to get repeated and that is used to access the data of that whole table is known as primary key, which means here it is student ID. Okay, let's suppose your student ID is a primary key here. Okay, but your instructor is a non-primary key, your course is a non-primary key, all the other key except primary keys non-primary key attributes. Okay, so your instructor should have directly dependent on student ID, but your instructor information also depend on courses, right? So to make it in 2NF, we are dividing it. Now your course depend on student ID and your instructor depends on course, which is again indirectly depending on student ID. So every data is dependent on student ID. If you want to fetch course and instructor from student ID, you can do that. You can write a query and fetch all the information. This means that your all non-key attribute is directly dependent on your primary key. So that is in 2NF form now. And the third normal form, it eliminates transitive dependency. It means no non-key attribute should be dependent on another no non-key attribute, which means all the second normal form you have just seen, okay, which says that all the non-keys should be dependent on just primary key. Now this is the third normal form, which says that the non-key attribute should depends on primary key but not on the any non-primary keys. So we'll take the same table. Here if you see, your professor depends on department, right, which is a non-primary key attribute. Now to achieve 3NF, we'll divide this. Now your department depends on student ID and your professor depends on department, which is indirectly depending on student ID only. So there is no direct dependency between two non-key attributes. This ensures that your table is in 3NF. Okay. So this was all for this video. Let me know if you understood the basic of normalization or you have issues in understanding key and non-primary key or primary key and dependencies. We will try to discuss all this topic in detail in coming videos. But if you want to understand something right away, you can still write down in comment. I'll get back to you soon. Thank you.